In problem number 16, we're going to find an equation of the tangent line to this graph. So the first thing I would do, just to get yourself kind of centered on what your task is, go ahead and sketch your function. So your function, when I put it in my graphing calculator, kind of looks like this. It's a cubic. So here is my f of x. Okay, next thing. Find your tangent line. So here is, say, where my 1 would be. So my tangent line, if I put that in blue, say, come up to your function and you're going to draw a tangent line right there. That's the equation I'm looking for. What do I know? Well, I see I have a point. That point is x. How would I get the y point? So the y point you're going to get by plugging your x back in your equation. So right here I want the y value. So if I plug 1 into 3x squared plus 2x, I'm going to get 3 plus 2 is 5. Okay, so now I see that I have a point on that curve. So my point is 1, 5. So I'm going to use that point in my equation. Because when I find the tangent line, the equation of the tangent line, what I'm going to really be finding is y minus, instead of saying y1, you should say f of 1, so as not to confuse yourself. Then instead of saying slope, you should say f prime of 1, and then this x that you're going to plug in is going to be the 1. Okay, so I found f of 1 by doing my graph and getting that out of the point. F of 1 is just 5. Now you have to find the slope at 1. First find the slope by taking the first derivative. That slope is going to be 3 times 3 is 9, 9x squared plus 2. Plug in your 1, aka evaluated at 1, and I get 9 plus 2, which is 11. Alright, so now I have all the pieces that I need. So my equation, so I'll change my color so you can see it. My equation is going to be y minus, what's f of 1? F of 1 is going to be your 5. So y minus 5 equals f prime of 1. That's going to be your 11 times x minus 1, and that's all there is to it. In problem number 17, they're asking us to find the equation of the tangent line to this graph. Alright, so what would be a good idea is to go ahead and graph that so we can see what we're doing. So here's my graph, here's my rule of 4. So I have pi over 2, pi, 3 pi over 2, 2 pi. This is sine. My new central line is at 3. So here's my new central line. Okay, so sine will start at the central line. So I'm going to need to know the point over here. So let me get that other point. Okay. This is 3, this is 4, this is 2. And now let's graph the sine. So sine starts here at the center line. Whoops. Let me go back. It's going to start here. And let me see how I'm going to do this. So it starts here. It's going to go up 1, down, down again, back up 1. So then I'm going to connect those lines. That's my f of x. Okay, they want to know the tangent line where x is pi over 3. So pi over 3 is not on my graph, so where would it be? Pi over 2 is a little bit bigger than pi over 3. So let's just say, for argument's sake, that pi over 3 is maybe right here. So I am therefore looking for that tangent line that's drawn right there. That's what I'm looking for. Let's now get our work. So the first thing we want to do is write out what they want us to give them back. So they want an equation of a tangent line. So they want y minus, and this is going to be f of x equals f prime of x over x minus x1. Okay, so now let's actually put in what we need. So I know what the x is. They want x to be pi over 3. I know what this x is, and I know what this x is. So let's plug in what we know. This is pi over 3. This is pi over 3. Alright, this piece is now done. Now let's find f of pi over 3. So f of pi over 3 means I have to take the original equation right here and evaluate it at pi over 3. So that's going to equal sine of pi over 3 plus 3. So what is sine of pi over 3? Come up and look at my unit circle. Sine is the second value. I drew the angle pi over 3. So the sine value is root 3 over 2. So this is root 3 over 2 plus 3. So can I do that in a prettier fashion? Why don't we say 3 is also equivalent to 6 over 2. So let's replace the 3 with 6 over 2. That enables me to write this as one fraction. Root 3 plus 6 over 2 is what f of pi over 3 is. Okay? So what I could do right now is I could replace f of pi over 3 in my original equation. So let's do that. So I'm going to erase f of pi over 3, and in its place, let's put what we just discovered. So minus, and then I'm going to use a bracket so that I can see the whole thing. So I have root 3 plus 6 all over 2. Close the bracket. Okay, that was f of pi over 3. Now we need to find f prime of pi over 3. So let's take this, and maybe what I'll do is let's erase this because we don't really need it anymore. So this is now gone, and I have to do something else too. Okay, I cleaned up our spot. So we now want to figure out what f prime of pi over 3 is. So first we need f prime of x. So look at your original function. What's the derivative of sine x? That would be cosine x. What's the derivative of 3? 0. So f prime of x is just cosine x. So now f prime of pi over 3 has to be cosine of pi over 3. Go back up to my unit circle again. What is the cosine of pi over 3? That would be the first value. That would be 1/2. Okay, so now we're going to go up and we're going to eliminate this from our equation because I now have a value. So the value I have is 1/2, and I'm going to put that right there for us, and we should be all done. So just to recap, I had to do a couple of different things. Have a systematic approach to these problems. Write out what you have to get and then do it systematically. Having a graph is always a good plan because I can see that my slope should be positive, and I did get a positive slope, so that's a good thing. So that's your final answer. That's the best form. Notice I didn't grab my calculator once. I was able to do everything by using my unit circle. If I give you an angle on the unit circle, I expect you to use the actual answers, not an approximation. Okay, in problem number 18, they ask us to find all the points. All right, so that's one thing. I had to find points. That means x and y coordinates at which the graph of, so here's a graph, has horizontal tangent lines. Alright, so we need to figure out where that would happen. If it has horizontal tangent lines, it must mean that the slope of the tangent line is 0. So this is telling me that the slope has to be 0. So find the slope. The slope is your first derivative. F prime of x equals, take your derivative, 3x squared minus 3. Okay, factor that. So I'm getting, factor back of 3, x squared minus 1. And now I could factor that further. X plus 1, x minus 1. Alright, so this slope will be 0 where this factor equals 0 or where this factor equals 0. So my answers are going to be either where x is negative 1, and that's from this factor, or where x is positive 1, and that's from this factor. Now, we're not done. If you write that answer, I'm going to give you half credit. Why would that be? Because it's saying to find the points. So, come up here and let's set up our coordinate pairs. If x is negative 1, plug a negative 1 back into your original function. And so you're going to get negative 1 cubed is still negative 1. So I have negative 1 minus 3 times negative 1 is a negative 3. So minus a negative 3 is plus 3. So that means that you're going to have a y value of positive 2 if x is negative 1. Now do the same thing with positive 1. So let me just erase what I had here. And let's do the same thing with positive 1. If you plug in a positive 1, I'm going to get 1 and then minus 3, so that means x is negative 2. Alright, and those are your answers. Those are the points where the graph of that function is has a horizontal tangent line. Now when you have these problems and you're doing a review packet, what you really should do is graph these functions. So this function, okay, so here's 1, here's negative 1 rather, here's 1. This function looks like that. So do you see how you have the horizontal tangent line right here and right here? So now we know that this y value is going to be a 2 and this y value is going to be a negative 2, and this problem makes perfect sense. So do this stuff for yourself. You have a graphing calculator. Please, please, please use it. Don't work in a black box. Have all the information you need so that your algebraic results that you got using calculus match up with the graphical results you can see on the graphing calculator. If they don't match up, you have a problem and you can go back and figure out where it is and troubleshoot.